So in our last class, we commenced a discussion on linear programming. And in that class, we said linear programming is an extension of single limiting factor. It's when you have more than one resource that is limited to an organization. And in that class, I remember I said that linear programming is a mathematical technique used to find the best decision when resources are limited. Not just a resource now, but resources are limited. So limiting factor is a concept that deals with how do I use what I have in the best possible way, where the resources are limited in supply. And in that class, we said there are various steps we must take note when solving linear programming. Number one, we must be able to define or identify our limited resources and define our contribution, which will serve as the objective function. The objective function, we said, is subject to certain constraints, which will be expressed in form of inequality. And once we express that in the form of inequality, we need to determine the non-negativity condition, which simply means you cannot produce negative quantities. And if the question wants you to go further, you convert the inequality into equation. And once you convert the inequality into equation, you determine the unknown variables, which can be represented on a graph. And those unknown variables represented on the graph, you can be asked to determine the visible region on the graph. And we said the visible region is the region or the area that satisfies all constraints at the same time. So every point inside this region is termed as a possible solution to the limited resources. So the optimal solution, we said, lies at the corner of the visible region. So we solved an example in that class, and tonight we're going to revisit these assignments to know what the issue is. Then there is a question I will forward again to the platform that will lead us to the issue of shadow price, which is very important. So looking at this question, the question reads us that Peter makes two types of chair, the executive and the standard. The data relating to each are as follows. We have material, standard 2 kg, executive 4 kg, labor, we have 5 hours, and for standard, for executive 6 hours, contribution $6 for standard, executive $9 for executive, and there is a maximum of 80 kg of material available each week and 180 labor hours per week. It means in a week you cannot have access to materials above 80 kg, and you cannot have access to labor hours above 180 hours, in a week. That is the limit. So those are the limitations. So demand for standard chairs is unlimited. It means standard chair have no limit, have no restriction. Customers can demand to any length. So there is no limitation regarding standard chairs. But maximum weekly demand for executive chairs is what? Is 10. So if you are expressing that executive chairs in the form of inequality, what will that be? It will be executive chair cannot be what? Greater than what? Cannot be greater than 10. And when you want to express it in form of equation, what will that be? It will just be executive chair is equal to 10. So when you are representing it on a graph, it will be a straight line. Yes, when you're representing it on the graph, it will be a straight line. Where you have executive and it is 10, you just draw the straight line upward. And that is the representation of that on the graph. And that is where most of us could not show that on the graph. So to solve these now, question says find the optimal production plan and the maximum contribution that these will generate. The optimal production plan and the maximum contribution that these will generate. So the first thing we are to do is what? From our previous knowledge, what will be the first thing we are to determine? Let's see. We have our contribution given directly. Yes, we don't need to solve for it. It's given. So the question now is, what is your objective function? What is your objective function?
Maximize contribution.
It's to maximize contribution. The objective function is to maximize contribution. Objective function is to what? Maximize contribution. Maximize contribution. And contribution for standard chair is what? Is $6.
$6.
For executive is $9. So when you are presenting this, it will be what? 6x plus what?
Plus 9e.
Plus 9e. This contribution is subject to what?
It's subject to constraints.
Subject to constraints. The question is, what are those constraints? What are those constraints? The constraints are what?
Material, labor, and demand.
Yes. Material, labor, and demand. Material, labor, and demand. Now, the maximum quantity of material is stated per week. The maximum labor hours, the maximum labor hours.
Excuse me, I cannot see your screen. I don't know whether it's peculiar to me alone. I can't see your screen, sir. Maybe it's my network, I don't know.
Okay, if I may just chip in, could you scroll up, bypass I believe right now your screen, you're seeing all the participants, right?
Yes.
Same here, I cannot see your screen, sir. Yesterday, the same thing happened to me.
And just do what I'm saying now. Just scroll up, bypass all the participants. The next thing you see is the screen.
It's the same thing. I'm seeing it is only you that is appearing, no screen.
I can't see your screen.
Just slide, put your finger on your screen and slide down. And do it again if need be.
We can't see the screen.
It's the same thing. It's the same thing.
If you're actually looking at the participant, just put your finger on the screen, slide down once, slide down twice, and the third time you just see the screen.
I still can't see it. I'm only seeing the participants.
Hello, sir. It is only your picture that is showing there.
Slide down, you see it.
Don't worry, once you can't see my screen and you mention you can't see my screen, no issue. I will reshare my screen.
Thank you, sir.
Yes. You know, one thing I always try to avoid is noise during the recordings. You understand? So that when you are listening to it, you will not imagine what are the people talking. Yes. So once you just give a comment that you can't see my screen, I will just reshare again. Can you see now? Can you see the screen now?
No, sir.
No, sir.
Fine. Let me reshare again. I'm resharing now.
I can see the screen now.
Sir, it's on now.
Okay, fine.
Thank you, sir.
All right.
I can't see it though.
Your network.
Hello?
Hello?
Doesn't mean we have to sign out and log in back.
You are free to do that. Anyone. The class is not filled, so it's a free class. So
Okay, sir.
once you sign out, you can easily log in and come back. All right. So the maximum quantity of material per week is 80 kg. The maximum in terms of labor hours is 180 hours. So, but per unit, for you to produce 1 unit of labor of standard chair, how many hours do you need? 5 hours. For you to produce 1 unit of executive chair, how many hours do you need? 6 hours. In terms of material, for you to produce 1 unit of standard chair, how many kg of material do you need? 2 kg. Of executive chair, 1 unit of executive chair, you need 4 kg of material. So these are the constraints. And also in terms of demand, you can only give out executive chair of 10 in a week. So how do we express this in form of inequality? How do we express this in form of inequality? Hope you can see my screen, please.
Yes, sir.
All right, it's fine. So at intervals, I'll ask that question. Hope you can see my screen. So materials. To produce 1 unit, you need 2, right? 2 kg. So it will be 2x plus what?
Plus
Plus
4E.
4e. And this will be less than, or is it greater than now? To be less
It's less
than
than or equal to 80.
Less than or equal to
than or equal to what?
80
80.
kg.
Less than or equal to what? 80 for material. Because you cannot have material above what? 80 kg. For labor, it will be what?
It will be 5S plus 6E.
5s plus what?
6E.
Plus 6e. And will it be less than?
Less than or
Less
equal
than
to
or
180.
80
Less than or
hours.
equal to 180. For demand, how are we going to express that? For demand,
It's less than or equals to 10.
fine. So it will be executive chair less than what? Or equal to what? 10. Less than or equal to 10. Do you see the expression? For those of you that attempted it, this is how to express it. Executive chair will be less than or equal to 10. So having done this, what will be the next thing from your steps?
Non-negativity.
Non-negativity constraint.
Non-negativity. And this can be expressed as what? X, comma,
X,
E
E,
will be what? Greater than or equal to what?
equal to 0.
He's Jerry. He's Jerry like very smart. I said Jerry is very smart. He's not true. He's not that smart. I said it.
So when you express this as non-negativity, the question is saying what? Let me go back to the question. That's find the optimal production plan and the maximum contribution that these will generate. Just 1 minute, please, since somebody's. Yes. So the question is saying that find the optimal production plan and the maximum contribution. So it means we need to go further. That we will not stop here. We will not stop here. Because we are asked to find the optimal production plan. So for us to solve this, to determine the optimal production plan, what are we going to do? What are we going to do to determine the optimal production plan? We still need to express this to get the values of the unknown in the question and represent it on a graph. And represent that on a graph, just as we've done. So we'll convert the inequality into equation. We convert the inequality into equation. Hope you can see my screen.
Yes, sir.
Yes, sir.
We convert the inequality into equation. So the two major conversion, let's see it. These are the inequalities. These are the inequalities. So to go further, when you convert this inequality into equation, what would that be? Material will be what?
2s plus 4e is equal to 80.
Material will be 2x plus 4e equal to what?
80.
80. And we have these as what? Labor. Labor. These will be what?
5s plus 6e equals to 180.
6e plus is e equal to 180. And demand will be what?
E is equal to 10.
E is equal to 10. So demand have defined itself, isn't it? That in terms of demand, E is equal to 10. The definition is so clear and definite. It's a definite definition. So when we want to determine the value of unknown, so we now express these, the value of materials and labor. We'll make material equation 1 because the value of S and E in material and labor is not defined. So we want to get the definition. So material is what? Equation 1. Let me go to another slide. Material is equation 1. Labor will be equation 2. So the demand is already defined. The value of E is 10. So there is nothing you are looking for. There is no any unknown in that limitation. So for this, if material is equation 1, and labor is equation 2, to get the value of X in equation 1 and equation 2, to get the value of E in equation 1 and equation 2, what are we going to do? You look for a variable, you can, or a value, you can multiply with what? Equation 1. For you to what? To eliminate, for you to have, let's say, 2x and 5s to be the same. Or you look for a value you can multiply for you to have the value of 4e, to make e and e in equation 1, and the value of 6e to be the same. Yes. So what can you multiply by equation 1 for you to get same value for x? We
Question
can,
question one can be multiplied by 6, and question 2 can be multiplied by 4.
okay, fine. That is for to make e equal. Yes, to make the values of e equal. And you can also multiply equation 1 by what? By 5, and equation 2 by what?
By 2.
2, to eliminate, to make the value of x equal. So you can eliminate them. You will now be left with what? That of e. Then you look for the value of e. So let's multiply equation 1 by 5. Let's eliminate x, and equation 2 by what? By 2.
By 2.
So the point is 5 multiplied by 2x, you have what?
10s.
You have 10x. Plus what? 5 multiplied by 4x,
20e.
20e, equal to what? 400. That is 5 multiplied by 8 is 40. You have 400. Now 2 multiplied by 5x, you have what? 10x. Plus what? 2 multiplied by 6e,
12e.
12e. And 2 multiplied by what? 180,
So that's 360.
360. So when you minus this equation here from these, the result will be what? That is 10 minus 10.
0.
10s plus 10, 0. 20 minus 12e,
8e.
8e, equal to what? 360. So for you to get the value of e, what will you do? If you cross 0 to this other side, it will be minus 360 minus 0 is what? 360. The equation will be what? It will be what? 8e equal to what? 8e. Okay. Sorry, this should be 40, right?
I wanted to say
8e
40.
equal to 40. So you divide both sides by 8 to get the value of e. And divide both sides by 8 to get the value of e. You have what?
5. Our e is 5.
So e will be equal to what? 5. E will be equal to 5. So when you substitute the value of 5 into any of the equation above, into equation 1, you can substitute to get the value of what? Of x. You can substitute into that to get the value of what? Of x. So when we do that, what will be the results? What will be the results?
It will be 2s plus 4 multiplied by 5 equals to 100.
Okay.
S is equal to 30.
S will be 30.
Okay, s is equal to 30. Right. Yeah, s will be equal to 30. We can just show that here. So we substitute into equation 1, right? That is 2x plus what? Plus 4e. 4e equal to what? 80. So if we are substituting e into this equation, it will be what? It will be 2x plus what? Plus 4e.
Multiplied by 5.
4 multiplied by 5 equal to what? 80.
400. 80 multiplied by 5.
Okay, so 2x plus what? 4 times 5 is what? It's 20. Equal to what?
80.
80. So when this 20 cross to the other side, the result will be what?
60. 2s plus 2s equal to 60.
2x will be equal to 6. That is 18 minus 20.
Yes.
So when you divide both sides by 2,
Get
the
30.
value of x will
Our
now be
answer is 30.
x will be equal to what? 30. X will be equal to 30. And you divide both sides by 2. You divide both sides by 2. Yes. But there is something. Just for equation 1. Just for equation 1 alone. For equation 1 alone. Okay, when e is 5, x is what? X is 30. Okay. So for equation 1 alone, if we make x 0, what will be the value of e? If x is 0, what will be the value of e?
20.
20. If e is 0, what will be the value of x?
40.
20.
40. Fine. Let's show that. Let's show that. Thank you. Because those are the coordinates we represent on the graph. Those are the coordinates that we form our graph. So we now have it. If x is equal to what? 0, e will be what? E will be what?
You will be trained as
That is 2 into the bracket of 0 plus what? Plus 4e is equal to what? 80. 2 multiplied by 0 is 0 plus 4e equal to what? 80. When 0 cross to the other side, it becomes negative. So we have 4e equal to what? 80 minus 0 is 80. Divide both sides by what?
4.
By 4. E will be what?
20.
20. So when e is 0, when e is 0, when e is equal to 0, what is x?
Spot.
X will be what?
40.
Yes, I don't think I need to show that again. 40. So take note of this. So for labor, when x is equal to 0, What is E? What is E?
Is finances. Huh? Is it 180 or 80?
80, sir.
It's 180.
Okay, 180.
So E is 30.
30.
So E is 30. And when E is 0, when E is 0, X will be equal to what?
36.
X is 36. X is 36. X is 36. So based on this computation, the question will now be, can we represent this on a graph?
Yes, we can.
Which those I can see some persons have represented that on the graph. Let me go back to the group chat and see some of the graphs. And let me see the results some of us have. Yes, 20 Y. Okay, solution table. Okay, very fine. I can see somebody have done a very good job. Yes, a very good job. I don't know if Greg Agim is on this call. Greg Agim, are you on this call? Yes. Okay, I can see. I'm looking at your work. You've done a very good work in terms of the solution table. In terms of the solution table, yes, because if we go back to the question is asking us the maximum contribution that this will generate, and I can see the expression you've done, your solution table, which is a very good one, using the contribution, yes, to derive $225, and that is the maximum contribution. Let me visit one more again. Temi, that is Tokwe. Yes, Tokwe to have he has expressed it well. The solution table is very fine. $225,225. Yes, she has also done a good job. And let me see. Madam Victoria, she has also done a good job. Yes, that is nice. Those are the 3 on the platform. Those some sent directly to me. Ordered directly to me. Yes. So now, to express this, all these variables in a graph, the graph will, let me still go back to this graph. Yes, the graph we are seeing for, let me just put a full stop so you see the graph on the platform. For Mr. Gregim, the graph is fine, but there is just a missing line there, which is that of demand. Demand is what is 10, and the 10 is for what? The executive chair. So when you represent all these, you're supposed to still show that of demand, the value of demand on the graph. Let me show you my own graph. I should have a graph here. Let me show you my graph. So this is how the graph is supposed to look like. So if you look at, I'm looking at the ones on the group, yes. So you can see the standard, the executive. So when the standard, when your standard is when you solve and your standard is what are the value of standard now? When E is 0, what is X? When we solve, when E is 0, our S range between 35, right? 6. When E is 0 here, what is X? X is what?
36, I think.
36.
36.
36, fine. You can see it here. So when X is 0, when X is 0 here, what is E? E is what? Check your solution. When X is 0, what is E?
Is 4.
20.
Okay,
20.
when X is 0, E is what?
20.
E is 20. E is 20. So, but in each of those equations, let me go back there. Let me copy my results. In each of those equations, this is what I want. For equation 1, for that line 1, for line 1, for example, for labor, this result here, when E is 20, when E is 20, X is what?
0.
Yes, when E is 20, no, when E is 20, X will be what? 40.
It will be 40.
Yes, when E is 0, X will be what?
40.
So on the graph, let me go back to the graph. On the graph, this is it. When E is 20, S should be what? 40.
40.
So you put your asterisk here, you connect the two lines. So on the other part, when X is 36, what is E? Check that equation. E is what? Check the solution. You didn't write it. I don't want to keep going up and down.
E is
So,
30.
fine. So that is how you read the graph. You read the graph. So when X is what? 36, E is what? 30. You connect. So for demand is just equal to 10, right? And for which chair is it? Executive chair. So you have it 10. Draw it upward. A vertical line. So this is the expression of those variables on the graph. This is how to express it on the graph. So for those of us that have submitted, this is the correction we need to take note of. This is the correction we need to take note of. So in terms of contribution, the best contribution will be at this point where the two lines connect, isn't it? At this point where the two lines connect, everybody that have submitted, we've actually done well with respect to the contribution. So the contribution will always be at this point. So these two lines of connection is the point where we solve for the simultaneous equation by elimination to get the value of what? Of E, and to get the value of what? Of X at the point of what? At the point of intersection. At the point of intersection. So those two values we obtained. Those two values we obtained. That is the first thing we solve for. The two value we obtained when we solve for the equation, that is these values here. 5 for E and X for 30. These are the quantities at that point of intersection. These are the quantities at the point of what? Intersection. So for you to get the contribution, the maximum contribution, what are you going to do? For you to get the maximum contribution, what are you going to do? The contribution we have in the question is what?
10.
10. Is it just 10? We have two contributions for...
Sorry, 6 and 9.
Yeah, so based on our objective function, the contribution is equal to what? 6x plus what? Plus 9e. So to get the maximum contribution, what will you do? The two value of the unknown of standard chairs and executive chairs at the point of intersection, we are going to substitute into this contribution equation. So C would now be equal to what? 6 multiplied by what? The value of X is what?
5.
By what, sir?
5.
No, sir.
No, it's by 30.
Or 30. One is 5, one is 30.
Yes. Okay, fine. So the value of X is what? Is 30. The value of X is 30 plus what?
Plus 9 multiplied by 5.
9 multiplied by 5. So your contribution will now be what?
180, above 180 plus 45.
Plus 45. And this will give us what?
25.
225.
So when you produce 5 executive chair and produce what? 30 standard chairs per week, the maximum contribution you will have will be what?
225.
Will be 225. Will be 225, because at that point we have the point of intersection. So you can check what other people have done using the solution table on the platform. You will see they've used the approach we showed in the last class. Because we have on the graph, you have 3 points, yes, showing the visible region. So at point X, that is what Mr. Gregory has done. At point X, at point Y, at point Z. Yeah, so you can label your own anyhow you want. So the point of intersection at point A, at point B, and at point what? At point C. Yes. What are the contribution at those points? Yes, if you look at this, you see 4 points. But at these 4 points, is very clearly defined. Yes, this is just for what? For demand. But in terms of the limited resources, A, B, C, what are the values at this point? Yes. So if you check the workings of others, you see what they've done. You see what they've done there. 636 90 635. When 6 is 0, 6 is 0, y is what? 20. So that is what they've done, which is very fine. So this is the issue about the assignment. This is what we have to talk about the assignment. Any question, please? So if you've not solved it, the fact that we've shown the solution does not mean you shouldn't attempt it again. Attempt it again. And everything we are doing after the class, make sure you solve them again. Yes, you solve them again.
Okay, sir.
It's very important. Yes. So please do solve it again. Definitely, you will make mistake at one point or the other. But the fact that you are making mistake does not mean that you cannot know it, or does not mean that you don't know it. Yes. When you make mistake, it's for you to learn better and take caution when next you are solving it. So don't always write yourself off because you make a mistake, you didn't get it. You say this thing is hard. That is how some students behave. They think it will just be like a magnet. You still go back and study it before you can make boast of it. So that is the learning process. That is the learning process. So we'll look at another question now. I don't think I have the question on this slide. Let me check the other slide if I have it. Linear programming. Let's see. I have it. If I don't have it, I will share the question on the chat group.
Product line to be established. But it is, however, possible to utilize all the available resources in the process of manufacturing more profitable product line.
Sorry about that. Trying to get the slide that I have the question.
Hello, Sam.
Yes, ma'am.
I'm sorry, I was logged out by the network. So I have questions. I still don't understand why we didn't solve for the point C.
Why we didn't solve for what, ma'am? Hello?
Can you hear me?
Yes, I
C.
can hear you now.
Why we didn't solve for point C? I said I don't understand why we didn't solve for point C.
No, we actually solve for point C. Is point D we didn't solve for because it is clearly defined.
But I thought the point of intersection was between demand and material.
No, the point of intersection based on the equation is between what? Standard and what? Standard and executive chair. This point here, this point B. And that is why we solve using, point D is not an equation per se, is a defined variable. This D, this demand is defined already. this the D is defined.
My
So
network
the
is
two,
bad.
okay, the 2 points of intersection is point B, which is the point where we use equation 1 and 2, that is labor and material, to determine the values of standard chairs and executive chairs that can be produced at this point. So this point here is a defined variable. So this is not defined. We want to know what is happening at this point here. But if you still want, at point C, the 2 lines intersecting is what? Is demand
Demand and material.
and material. So when you solve for that, when you substitute the values into your equation, what will you have? What will you have? But the question now is, which value will you pick on this line? You understand? You know you have 2 points here.
Yeah.
Which value will you pick on this line? I don't know if you get that. So
I don't get it.
yes, you know the contribution you are getting for points A, B, and C, right? Point A, B, and C. So, okay, let us use the solution table. Your contribution is what? Your contribution
6x plus 9e.
plus 9e plus 9e. So now at point A, what is the value at point A? This point A here, what value are you having?
36.
36. Fine. So it shows we're going to have what? 6 into the bracket of what? 36 plus what? 9.
Plus 9 into the bracket of 0.
And this will give you what?
216.
216. So at point B, the point of what? Intersection.
Intersection.
Of 2 lines, the 2 limited resources. And we've solved for that. The results are what?
30.
You have
30 and
6
5.
into the bracket of what? 30
Plus 30.
plus what?
9 into the bracket of 5.
Of 5. When you solve this, the result will be what?
225. 225.
So at point C, what do you have?
So we have 20 as we have 20.
At point C,
Yes.
we have 20.
Yes.
That is when 6 is 0,
0.
or when x is 0, what is the value of
E.
E? So when
E
x is 0, what is the value of E? So the value of E is what?
180. 9 multiplied by 20.
So 6, 0 plus what?
9 into the bracket of 20.
Of 20. So we now have it as what?
180.
So let's take it further. So the next is what? This point D, right?
Yes.
So when E is 10. When E is 10, right? What is X?
0.
So that is, we have it as 6 is 0, right?
Yes.
Plus 9 multiplied by what? 10.
By 10.
So the value is what?
90.
90. Hope this is fine.
Yes, sir. Thank
Yes,
you.
but the question wants you to determine what?
The highest
This.
contribution.
Yes, the highest contribution. So this is what the question wants you to do anyway. So, but for knowledge purpose, this is the solution table. This is the solution table. So let me quickly forward the question. When you have too many slides, sometimes I easily get confused about the question. Let's see. Sorry, just a few minutes. Let me see. Okay. Clear. Let me just PDF. So I've sent the question. Hope you can see the question now. Hello, can you see the question now?
No, sir.
No, sir, we can't see it.
It's on the group.
It's not
Not
there
on.
yet.
Is there?
Somebody can read before I put it up on the. I send it to my laptop.
It has not dropped.
You can see the variation of Nigeria network.
So is it only limited?
Yes.
Oh, it has dropped.
No, you know you are in a different location. Maybe your
Oh,
network is.
It's just dropped now.
It has not dropped, though.
It has dropped.
So you can see this is a research topic.
That's dropped.
Variation of network in different location.
I've not seen no.
You see,
It
using
hasn't dropped
Nigeria
for
as
me, oh.
using Nigeria as
It
a
has
case.
not dropped.
See now. can see that. Or I'm sending it to my system. I'll make it available on the screen now. But you can read if you have it.
Platform, okay.
Okay, it has dropped.
Let me read. Hello.
Yes, sir. We are with you, sir. Read, sir.
Okay. Says Tolani Limited produces two products, Meso and Russo. Budget data relating to these products on a unit basis
Yes, sir,
for
you
August
dropped it on
2020.
our FM group. Not on
Okay, do we all
PM class. That's why some people did not see it.
Okay, it's true.
No wonder I've seen it in FM class.
All right, you can write on, sir.
All right. So Tolani Limited produces two products, Meso and Russo. Budget data relating to these products on a unit basis for August 2024 as follows. Selling price is 150 for Meso and 100 for Russo. Materials 80-30. Salesman's commission 30-20. Each unit of production incurs costs on machining and assembly. The total capacity available in August 2024 is budgeted to be 700 hours for machining and 1,000 hours for assembly. 1,000 hours of assembly. The cost of this capacity being fixed at 7,000 naira and 10,000 naira respectively for the month. Whatever the level of usage made of it. The number of hours required in each of these departments to complete one unit of output is as follows. Still under Meso and Russo, that's the products. We have machining. Under Meso is 1.0 units, while under Russo is 2.0 units. And assembly, under Meso is 2.5, and under Russo is 2.0. Under the terms of special contract or special controls recently introduced by the government in accordance with ECOMOG requirements, selling prices are fixed, and the maximum permitted output for either product in August is 400 units. At the controlled selling prices, the demand for the products exceeds this considerably. You are required to A, to calculate Brass Limited's optimal production for August 2024 and profit earned. 2, to calculate the value of Brass Limited of a marginal increase in the available capacity for each machining and assembly, assuming that the capacity of the other department is not altered and the output maximized on time to apply. Oh, wow. So I'm done. Hello, sir.
Okay, thank you, sir.
Yes, sir. But I'm not surprised. Why did the name change from Tolani Limited to Brass?
Yes, that is a mistake. Yes, it's still a mistake. You still maintain Tolan. In case you are writing it in your book, some people used to write it, so
okay, sir.
Yes. So looking at this question, we are asked to calculate Tolani's Limited optimal production 2024 and profit earned. Selling price We have material, salesman's commission. For each unit of production entails cost on machining and assembly. The total capacity available in August, you can see now, total capacity in terms of hours, the maximum you have in terms of hours is what? 700 hours. See, it's 700 hours of machining and 1,000 hours for what? For assembling. The cost of this this is a fixed cost now. 7,000 naira and 10,000 for the months. So whatever the level, irrespective of whatever the level of usage is, so the number of hours required in each of these departments to complete 1 unit of output is what we can see now. To complete 1 unit, you must always determine the value of 1 unit. So to produce 1 unit using machining to produce muscle, you need 1 hour. Using machining to produce Russo, you need what? 2 hours. Using assembling to produce muscle, you need what? How many hours? 2.5 hours. To produce Russo, you need 2 hours. So that under the terms of special control, recently introduced by the government in accordance with ECOMOG requirements, this is a limitation now. Selling price are fixed and the maximum permitted output, you can see the result, the maximum permitted output of either product in August is what?
400 units.
400 units of either product. It means for Maso, you can produce 400. For Russo, you can also produce what? 400 in August. You can see it's similar to the issue of demand we looked at just of recent, where the executive, you can only produce 10 chairs. 10 chairs. They are telling us that under the condition of ECOMOG, you can only produce 400 units. So at the control selling price, the demand for the product exceeds this. You can see you have more quota that have been fixed by ECOMOG, 400 units. So this is when you are expressing your constraint. It's for us to determine what? The first step is to determine what now?
Our objective function.
Our objective function. And for us to determine our objective function, what are we going to do?
We have to calculate the contribution.
Okay. We have to calculate the contribution. So for you to calculate the contribution, we'll have it in this way. Step 1. Step 1. The contribution. Determine the contribution. So we have 2 products. 2 products. We have Maso. We have Maso. We have Russo. The selling price of each of these products is what? Maso is 150. Russo is what? 100.
100.
So selling price, Maso 150, Russo is what? 100. To get your contribution, what will you do? Selling price less variable cost, right?
Variable cost, yes.
Less variable cost. Selling price less variable costs. And the variable costs we have variable material. We have material. The material in the question is what?
80.
30. So we have 80, we have 30. What other variable costs? Salesman's commission.
Salesman's commission.
So we have it, salesman's commission. And the value is what? 30? 20. So when you do the plus and minus, the contribution will be what?
We have 40 for the first one. And we have 50 for the second one.
40 and 50. So you can now show your objective function. 2. Objective function. Objective function. The objective function will now be what? Our objective function will now be what? Maximize what?
To maximize contribution.
Maximize contribution. And what is our contribution? 40 for M.
40 M plus 50 R.
Yes. So we have 40 M plus 50 R. And this contribution is subject for us to attain this contribution, to achieve this contribution, is subject to what?
Constraints.
Subject to constraints. So these constraints, what are they? They are stated in the question. See the constraints.
Maximum and assembly.
Also the ECOMOG limit in terms of in terms of demand.
Maximum output of 100.
So we now have it for machining. It will be what? It will be what for machining?
1.0 M plus 2.0 R.
Yes. Will now be, is it greater than or less than now?
Less than or equal to.
Less than or equal to.
To what? What will be the value?
It will be. Okay. 700 for machine.
Very good. Very good. Very good. So since that is 1, I will just represent it as what? M plus what? 2R. If less than
or equal to
700. Then for assembly,
2.5 M.
2.5 M
plus
2R.
Less than
1,000.
1,000.
And less than or equal to 1,000.
Less than or equal to 1,000. The next limitation is the issue of ECOMOG. So the ECOMOG is affecting 2 products. That is the Maso and Russo. In exam, you can express it anyway. The point is just show the expression, and the examiner will know that you understand what you are doing. So it can be Maso. Now, for Maso, what would be the expression? Let's say ECOMOG 1. The issue of ECOMOG 1 in relation to Maso. How are we going to express Maso? Maso will be what? Is it greater than or less than? The question. The supply of Maso that they've fixed and the maximum permitted output of either product in August is what? 100. So how would the expression be?
It will be less than.
M will be less than or equal to what?
equals to 400.
Equals to 400.
Less than or equal to 400. Then for the other products, let's say Ecomog 2. Then, which is Russo. Russo will be what?
Less
Less
than.
Less than or equals to 400.
400. So what next will you do?
Non-negativity constraint.
Negativity concept.
Your non-negativity.
Non-negativity.
Your non-negativity. And that will be expressed as what?
M
Ecomog 1,
Zero.
Ecomog 2.
You know, Ecomog 1 is still Maso and Russo. You understand? That is the product. You know, you are expressing the products. Do you understand? What are the products? Maso and Russo.
Yes.
So you cannot produce a negative. So
We go to the
Maso and
will be greater than or equal to what? 0.
0.
Greater or equal to 0. The question wants us to calculate BRAS Limited optimal production plan for August 2024 and profit end. It means we still need to go further for you to know the profit end. Yes, at this point, let me ask. For us to know the profit end, what are we going to do? Based on your past knowledge of on limiting factor, what are we going to do? Because in this question, I can see fixed cost, right?
Yes.
So what are we going to do? What should come to your mind?
We substitute
So
with the equation of substitute.
we're going to apply marginal costing concept.
Okay. Now, in the last example, you know, we were asked to determine the maximum contribution, right?
Yes.
So also in this question, you apply your solution table. Once you apply, you draw your solution table, the maximum contribution less your fixed cost will give you what? Your profit.
Profit.
Your profits.
Yes, the maximum contribution less the total fixed cost will give you your profit. So that is how you begin to reason it out. Yes, once you see profits and the question is not giving you something that it is very clear, just solve. Get your total contribution less your fixed cost, you get your profit. So for you to get your contribution, you must solve further. And we need to solve further. So what next are we going to do?
Convert
Convert
inequality to equation.
Convert the inequalities into equation. So from what we have, this inequality, we have this, we'll convert this and we'll solve immediately. This will be equation 1. Your machining will be equation 1. So if this is, okay, let's convert it. This is equation 1. For equation 1, you know, we need to determine the variable of M and R so that when we go to our graph, we'll be able to plot each of these points on the graph. So for equation 1, we need to get the value of M and R. For equation 1, when M is 0, when M is 0, what is R? When M is 0, what is R? I don't need to show too much drama again.
350. 350.
R is equal to 350. How did we get that? It will be what? 700 divided by what? 2.
2.
So when R is equal to what? 0, M is what?
700.
M is 700.
M is 700. That is what? 700 divided by 1. This is equation 1. For equation 2, assembling. For equation 2, assembling, it will be what? We have this equal to equation 2. So for equation 2, when m is equal to 0, R will be what?
500.
R is equal to 500.
500. That is 1000 divided by what? 2. So when R is 0, M is what?
400.
M is 400.
So we have it as 1000 divided by what? 2.5. The next is what? Equation 3. Let's show this. With equation 3. How will it look like? How will it look like? So for ECOMOG 1,
Yes.
for ECOMOG 1, M is equal to 400. But if you want to express when M is equal to 400, R is what?
0.
R is 0. For this ECOMOG 2, this is equation 3. This is equation 4. So the point is this: when M is 0, R is what?
400.
R is equal to 400. R is equal to 400. So can we plot this on the graph?
Yes, sir.
Can you try? Quickly do something. Let me see. Send to the platform. Plot it on the graph. Let's see. I want to see at least 5 graphs on the group. So if you are just listening to my class and you are not following, this is where I will know. Some people will just be listening to your discussion. We're having class, have your book in your front. People we are having class, they are running up and down in their room. during the class, you go and find a very special place to stay. And that's why if I'm having my class, I look for a special place to stay.
Is 350. Is 350. 350. And it's okay. Okay.
So we should be done with. Let me check the platform. Hope I can see attempts. People will tell me they don't have lights. Well, let me begin to see the people on this call. Let me follow up with everybody. Let me talk where.
Oh God.
No, you are my namesake. I'm from my hand. Okay. Okay, I can see Mr. Isa's special graph. Okay, very good. Yes, sir, let me analyze your graph. Sir, I can see two lines on 400. Two vertical lines on 400.
I'm just trying to. Okay, is it that one is okay for Ecomo 1 and 2?
You know, one of the lines should be for Russo, right?
Yeah, for is it Ecomo 1 and 2? The one.
Yes, Ecomo 1. Ecomo 1, you produce what? Russo, right?
Oh, yes.
Then you should have one line on 400, which is very correct. Then you now
Okay.
go to muscle and look for 400 and draw another line straight.
Okay.
Yes.
Okay. So that means let me represent that two lines to be one.
Okay, I
Please
can see who is this person. Okay, I can see
recognize it to be one.
Madam Odunayo. Okay, I think she has done well. She has represented well. Yes, she has done the representation very well. So you can see on my screen, you can see my presentation. You can see the presentation. This is how you're supposed to have it.
It's okay.
You can see the presentation.
Yes, sir. Does that mean we not have two line in on that 400?
No, see, muscle now.
One is for M, one is for R.
Yes.
Okay. So me, I just
Okay.
put the two on R.
I
That
put the
is
two
where
line on 400 too.
Okay. Yes, that is the learning process.
Yes, we are coming up.
Excuse me, sir. There is this question I want to ask. Does it matter where you put your variables? Whether, like me now, the way I represented my own, my R is on the vertical axis, while I put my E on the horizontal axis. Hope there is no penalty for that.
No penalty. Yes, you can anyhow. Once you identify 400 for muscle, this for this, it will still come up.
Okay.
Almost same.
Okay, sir. Thank you, sir.
So from your graph now.
Yes, sir.
Okay. The question is going to be.
Please show your graph again.
It's on the screen. And I'm Lundi, even went further to carry your children graph sheets.
Very serious.
I have to start learning how to use graph before I can now bring the graph. So let's start learning now, sir. Let's refresh our memory with the SS3 graph.
Sir, I can give us graph.
They might always have it around them. Where it is not available, you draw it. Yes.
Okay.
So I can see. Okay, that is nice. All right, let's forge ahead. So from
how do we
sir,
for your graph now, sir?
Yes, sir.
How do we identify the intersection? That
See
is, it's going to be okay.
Yeah. A, B.
So mine, I use the 350 and 700 points. So my own graph is kind of linear.
Okay.
Somehow.
Okay.
So,
yes, sir.
I know that from this one, if we are to work on the equation now to determine our maximum profit, to work for maximum contribution, I know we are going to use the M and R.
Yeah, it's the contribution, yes.
Yes, but what for instance now, if the question is not from that ECOMOG and we are to go further to join the two again between the M and R, how do we determine it?
Okay, to join the two, that is to determine the equation.
Yes, now this one, now our line will have it to be 4. Let's assume that 200, the 400 now for R and the 400 for M has their own figure. Like the one for R now, we assume that it has 500.
Yes.
M. So we are
Yes.
going to connect it to the line of M. And that of M is having like 300
Yes, sir.
in that R. We are going to connect it too. So from there, how do we determine our intercept to calculate for our equation to determine the maximum contribution? The constraint.
For you to determine the maximum contribution, the visible region is your point of concern. The visible region. Anything outside this point, anything outside this point of constraint is not important to you in terms of determining contribution. So the visible region, this region is what you are concerned about to determine your contribution.
Okay.
So if 400 connects for Maso connects to R, this point now, this is not the point of our concern. Yes.
Okay.
The point of our concern is this region here.
Okay.
From 0 to this point here, point B.
Okay.
So point A, B, C, which is your visible region.
Okay.
Because this visible region is the region that is bounded by your constraints.
Okay.
That constraint that you have, how can you use it to achieve the best contribution?
Yes.
So that is why our concern is on this region and not any point outside the region. And how do you determine this region? Once you plot your graph from point 0 to the first point of intersection, is what your visible region. Because sometimes students find it difficult to determine that from this point 0, move upward. The first point of intersection, what are the areas bounding it? Is your visible region. So now, to take it further, what will be your maximum, your total contribution using your solution table? Let's solve. Using your solution table, how will you get your total contribution? Using your solution table. Solution table. Using your solution table. The points we have point what? Point A, point B, point what? C.
See your screen, no.
Can anybody see my screen, please?
Yes, yes, I can see it.
Can see.
So our contribution is what? 40M plus what? 50R.
Yes.
And you have your total. You have your total contribution. The total contribution. So point A. What do you have at point A? The unit you have at point A is what? This point A. What is the unit here? Point A is what?
400.
400. So at point A, if M is 400 and R is 0, what will be your contribution?
1,600. Oh, 16,000. 16,000.
Let's jump to C. because we need to do some workings for B, right? So for C, when M is 0, what will be the total contribution? For R, the value of quantity at point C is what? 350. 350. So the total contribution will now be what? So now, for point B, what are we going to do to determine our total contribution at point B? I need the response now. Can somebody tell us? What are we going to do? At point B, this point B, something is happening here. What are we going to do to determine the value of contribution here? We don't know. That point of intersection, what two constraints, two lines are meeting at that point? What are the two lines meeting at that point?
Machining and assembly.
Machining and assembly.
Yes. When you have machining and
That's-
assembly,
Those are the products.
yes,
Maso and Russo. Mason and
Maso
Russo.
and Russo. Yes,
Yes.
Maso and Russo. Yes, but the question is which equations, the two equations intersecting? What are the two equations? The two equations intersecting at that point.
There is M plus 2R
R
is equals to 700
34.
and 2.5 M plus 2R is equals to 1000. Then we work for them, sir.
So those two equations are these are the equation lines, isn't it? The
Yes.
equation lines.
Yes, sir.
So
Yes.
at this point of intersection, those two equations intersect. They form these lines. So we have to substitute, use our simultaneous equation to
Yes,
solve,
sir.
get the value of what? Of
Get
M,
the value, yes,
and
and
the
get the
value
value
of
of
R.
R. Yes.
That will substitute to get the total contribution for point what? For point B. For point B. So what are we going to do now? For
So
point
I will-
B, don't worry, we'll solve it. Let's solve it together. The time is against us now. We are still going somewhere. Point B, we need to connect equation 1 and equation 2.
Yes.
So equation 1, 2.5 M plus what? Plus 2R is equal to what? 1000.
Equals to 700. Okay. Yes, 1000.
And M plus what?
2R.
2R is equal to what?
Equals to 700.
700.
Yes.
Equal to 700. So in this equation, we already have 2R and 2R appearing on both equations, right?
Yes.
So we can just minus directly. 2.5 M minus M, you have what? 1.5 M.
1.5 M.
So 2R minus 2R is what? Is 0. Is 0. So this will give you what? 300.
300.
So to get the value of M, it will be what?
22.
M will be equal to what?
300 over 1.5.
200.
300 divided by what? 1.5.
200.
So to get the value of R, what will you do?
Substitute M into any of the equations.
Okay, let's substitute M into equation 2. If you substitute into any of the equation, you get same result. In equation 2. So we have it as what? 200
Equal to 250.
Okay. Okay. The equation is okay, fine. Equation 2, that is 200, because 200 multiplied by M is 200.
200, yes, sir.
200. So plus what? Plus 2R equal to what? 700. So the value of R will now be equal to what?
250.
R will be equal to what? 250.
700. Yeah, 700 minus 2.
Yes, that is. We have it as what? 500 divided by 2. So the value of M and R at point B have been determined. So for M, we have it as what? 40 into the bracket of what?
200.
200 plus what?
Plus 50 into the bracket of 250.
Of 250. And this will give us what?
500.
So the optimal contribution based on this is what?
B.
Point B.
Point B. If you are now asked, what are the optimal mix in terms of units? What will you say? The optimal mix in terms of units. What will you say? The optimal product we need to produce that will give us the highest contribution. What are you going to say?
C.
The optimal unit will be produce 200.
It will be 20. Okay.
Produce 200 Maso and produce 250 units of what? Of Russo. When you produce this combination of products, it will now be what? It will now be, I can see your message, Mr. Charles, that you can't see my screen. Let me reshare.
It will be 450 units.
So,
okay, so thank you.
So,
okay, I can see
the units, the optimal mix is 200 units for Maso and 250 for what? For Russo. So the question is asking us, calculate Brass Limited optimal production. The optimal production should be 200 units of Maso and 250 of what? Of Russo. Of Russo. And profit end. So the profit end in the month of August will now be what?
Fixed assets divided by
the highest contribution less fixed asset.
per contribution.
Optimal product mix.
Okay, fixed costs. So, remember to take contribution.
So the profit end. Profit end will now be what? Profit end will now be what? Your total contribution will be what?
Contribution minus fixed cost. The total contribution is 20,500.
450. Okay.
20,500 less fixed cost.
2,500.
Total contribution, which is what? 2,500 less fixed cost.
Less fixed
No
cost.
fixed cost.
Less fixed cost. The fixed cost is what? What is the fixed cost?
7,000.
17,000 total.
17,000 total.
Okay, better. So fixed cost is 10,000. Let me write it. Somebody might ask, how did we get 17,000? 10,000 plus 7,000 is in the question. In the question. When you read. So when you add both, it gives you 17,000. 17,000. So 2,500 less 17,000. You're going to have what?
3,500.
So this 3,500 is your profit. Is your profit. Hope this is clear.
Yes, sir. Thank you.
Yes, sir.
No, sir.
Okay.
Yeah,
Guys,
sir, please, I was thrown out for a bit, and I don't understand how you calculated ABC to be 40 in bracket 400. I don't understand how you came about it. I would really appreciate if you can about it.
now from the previous class, to get your total contribution or to get your optimal contribution, the highest contribution, you use the various points within the visible region to determine that. And for you to determine that, you need to call back your contribution. Now, your contribution is what? 40M plus what? 50R. So, for you to get the contribution at each point within the visible region, point A, B, C, you need to ask yourself, how many units have you produced on point A? Is what? So to get the total contribution at point A, what will you do? We have this contribution equation here. So when you have 400 units, your contribution will be what? 40 multiplied by what? 400 units. At this point, R is what? 0 units. So your contribution at point A will be 40 multiplied by 400. You have a total contribution of what? 16,000. So at point, we skip B to solve for it later, which we just concluded. At point C, we ask ourselves, how many units did we produce at point C? Is what? 350. It's 350. Now, based on this, and the unit is what? Is Russo, right? Russo. So if you have 0 Maso and 350 Russo, and you substitute into this point, what will you have? Your total contribution will be what? 50 multiplied by 350, you have what? 17,500. Now, this point B, there is a marriage at that point. What is the marriage? The marriage between what? Equation 1 and equation 2. This is the point of interception. At this point of interception, we need to know what are the number of units that will give us the contribution at this point,
Hmm?
based on the fact two lines have intersect. Now, that is why we now solve using this equation. That point B, we have two equations intercepting. Now, we need to get the value of M at point B, the value of R at point B. The value of M at point B is what? You use your elimination approach of simultaneous equation. Now, we have two equal values here. We don't need to go far to look for what to multiply by each of the equation. We said 2R minus 2R is what? 0. 2.5 muscle less 1 muscle will give you what? 1.5 M. And 1,000 less 700 will give you 300. So when you collect like times, 0 cross to the other side will be 300 minus 0. You still have 300. 1.5 M, 1.5 muscle. You divide both sides by 1.5. You have muscle to be what? 200 units at point B. What is the value of Russo at point B? It is what? 250. So when you come back to this point, at point B, muscle is what? 200. So you say 40 multiplied by 200, you have a value. At point B, Russo is what? 250. 50 multiplied by 250, you have a value. When you add both together, you have what? 2,500. So that is how we place at this point.
Thank you so much.
All right.
Sir, please. Hello, sir.
I'm with you, sir.
Sir, please, if we at the point of intersection and we pick the equation from there, equation 1 and 2, and we work on them, we arrive at the value of M and R.
Yes, sir.
And we substitute for them. Then we move down to the maximum contribution and we use it like that without using the table. Is
Yes.
it okay too?
Very fine, sir.
Okay, sir. Then please, I send one question, I mean the graph regarding relating to the question I asked for you to help me look at it. If how we can determine the intersection from the graph there. Please help me look at it. I still use the same graph here to get it to give example of my question, please.
Okay, though I've not seen your message, sir.
So I send it to the platform.
Okay, I'm checking. I've not yet seen it anyway. All right, Temitope.
Yeah,
Okay.
please, I want to ask, is there any points we can have more than 3 points? Like, is there any question that we can have more than 3 points?
Very well, very well. If you check the question we saw before this, we have A, B, C, D, right?
I joined late.
Wow, you joined late. That is serious. That assignment that you solved, man.
Yes, sir.
See it, man. You see it.
Okay. Okay.
You
I'll watch
watch
the
it.
video again.
Okay, fine. Thank you.
So I forwarded it again.
Don't worry, I've seen it, sir.
Okay.
Yes, Mr. Babajide.
Thank you, sir.
Yes, sir.
Okay, so my question is that that's point of intersection.
Yes, sir.
So how can we actually know the specific equation to use? Because that is the major area that has been giving me confusion as far as this topic is concerned.
Sir. Okay. Is a point of concern, but I don't want it to be a point of concern again. I want it to be something you can easily match and cross. Yes. So this is it, sir. The point of intersection. You just go straight to your graph. Trace the two equations that make up this point of intersection. The two equations. The two equations. So, sir, this line, which equation is this? Which equation is this?
Well, okay. Sorry, I can't really, I can't give an answer. I'm sorry, sir.
I think you joined later.
Yes, I joined later.
Because if you've been in this class, I would have been hearing your voice. Okay. All right, sir. This line, sir. This line.
Okay, sir.
Is equation 2. See, it is labeled here. This
Oh,
line.
okay.
Then this other one is equation what?
One.
Equation 1. Equation 1. So the two lines that intersect, the equation that make up the line is what you have to use.
Okay.
To determine the values of units at this point.
Okay.
This point. So that is how to determine the contribution at this point, and that is why we always use two equations. You can see the equation 1 and equation 2. We used it to, yes, you see point B. We use equation 1 and equation 2 to get the two values of M and R at this point here. At this point here. So after this class, I'll refer you to the question in the Pathfinder. So you go and solve.
Sir.
You go and solve and come and tell me the point of intersection and the limiting factor using the graph.
Okay, sir. Okay, sir. So I still want to ask one or two more questions. So now, is it possible that we have 2 points of intersection, 2 points of intersection in a graph of this nature?
Yes.
Is it possible?
Very well. It is in this question, in this graph, we have more than 1 point of intersection.
Okay, I mean around the feasible region. Around the feasible region.
No, the visible region will definitely carry 1 point of intersection.
Okay.
Yes.
Okay.
And when you have more than 1 point of intersection, you will still need to determine those two lines that make up what? That intersection within that visible region.
Okay.
Yes. So when you have more than 1 point of intersection within that visible region, it will still be different points, different lines that intercept. So you trace it. What are those lines that make up that intersection within the visible region? You work it out. Yes. But most often, it will definitely be the 1 point of intersection. Yes. But where it is more than 1 point, you still trace it. What is that equation that make up this? So this is just like point of equilibrium. You understand?
Yes, sir.
Yeah.
Okay.
Sir. Hello, sir.
I'm with you, sir.
Relating to your explanation just now, if you have the two intersections like that, so the first one, you work it out, and the second one also, you work it out, sir. Separately.
Very well, separately. In extreme.
Yes. In that too now, if you have a fixed cost in the question, you to determine your profit. So you are going to use the fixed cost to the first one and the second one.
No, out of those two visible regions, one contribution must be higher. The contribution cannot be the same. So you are working based on your contribution. Yes. So you will not do this minus this to get a profit, this minus this to get a profit. No. The objective of this table is to get the maximum contribution, sir.
Okay.
Yes.
Okay. That means, okay, we will work for the maximum one. Okay.
Yes.
Sir, please, sir, I still have one more question, sir.
Right on, sir.
Oh, yes, sir. Thank you. So now there is a question. There is a question in the Pathfinder November 2021. So that question obviously has more than one limiting factor, and then ordinarily based on what um I've learned about, based on what you have taught us about limiting linear programming. Ordinarily, I would have use the linear programming approach. But now I saw that in the solution they said that it was they treated it as single limiting factor, and the examiners said that a lot of candidates
Yes.
made a
Yes.
mistake that they treated it as a linear programming while it was single limiting factor. So so it can be confusing. So I
Yes.
don't know if maybe you can take your time to check it, and then probably during the next session you can enlighten us to make us to see the likely pitfalls and so on, sir.
Yes. I think I know that question.
Okay,
November.
2021. Okay.
Let me just go there now. Let me go there.
It's not in, okay.
My screen is not showing. I'm on the main slide. November 2021. Because in the next class, I'll be thinking of something else. And if I promise you I'll check, I might not check. So let me do it now.
Okay, so it's a compulsory question and it's a 40-mark question. So it was that year when they made the compulsory question to be 40 marks.
I'm heading there now.
Okay.
November 2021. Sorry, taking your time. So I've done a quick search so that to make it much more to land me there. You don't even know. I'm just scrolling there.
Hello, sir. So sorry, May 2021. Sorry, May 2021.
Okay, fine. All right, I'll get there now. May 2021. Okay, May 2021. Already in May 2022. May 2021. The managing director of Interms Manufacturing Company.
Oh. I'm sorry. Please pardon me, sir. I'm so sorry. I'm so sorry, sir. It is November 2021. Although both of them are linear programming questions, but this particular one I'm talking about is November 2021. I'm sorry, sir.
Okay.
Yes, sorry.
November 2021. Kike Lomo. Sir, this is my Kike Lomo now. This one is walkover. I gave you as an assignment. This one is very clear. It's limiting factor. I know this question. This is my favorite question. You should have mentioned Kike Lomo, and I will know that you are talking about my question. This one is a clear limiting factor question, sir. Yes, it's a clear limiting factor question. I gave it as an assignment. Only maybe one or two persons, Madam Victoria Oni, she submitted on the platform, though she said she need help at some point, even though I've not responded to that help. Yes, though I did a video on my YouTube regarding this question, though I don't just want to refer her to the video, I want to attend to her. So this question is, there is another question that I was thinking you're referring to. I asked them to solve it in last diet. That one is very tricky, a limiting factor question. I think it's 218 likewise. So this question is, when you settle down and check it, is when you test for the limited resources, you will definitely know that it's a single limiting factor question and not
okay, sir, I will take my time and search and really search that question and then post it to the group, sir.
All right, no problem, sir.
Thank you, sir.
All right, sir. Yes, very quickly, we need to round up now. Where I want us to drive to as far as this question is concerned is on the concept of shadow price. Yes, the concept of shadow price. Shadow price, you can be asked questions theoretically on it that explain. Another word for shadow price is dual price. Yes, dual price. So the big part of the question says to calculate the value of brass limited of a marginal increase in the available capacity for each of machining and assembling, assuming that the capacity of the other department is not altered and the output is maximized on time to apply. In the last class, I defined what shadow price is. I said shadow price represents the extra contribution derivable from an additional unit of a scarce resource, which has been fully utilized at the optimal level of activity. Another word for shadow price, I said it can be marginal contribution, marginal contribution or marginal increase as a result of the addition of one scarce resource. So this question is not telling you calculate shadow price. It's just telling you marginal increase. You should know it is shadow price because when you add one more scarce resource, what will be the new contribution different from the old contribution? So there should be a new or increase, a marginal effect. You adding one unit of a scarce resource to produce a product. So there are various ways you can compute shadow price. So, but for this class, we'll look at the simplest arithmetic method where you add one variable, one unit of scarce resource to the available maximum quantity given. So we quickly do that so that I will refer you to the question in the Pathfinder where they use this approach. Likewise, where they use this approach, I think there is a question I solved during one of the revision class that requires that. SKD holdings, I think, is also a question in the Pathfinder. Yes, let me see. So I think this question, yes, solution to May 2021 question 1, biggies and smallies. See, yes. So there is a question I will refer you to that involves shadow price. Well, let's treat this. Now, to solve for shadow price, we said when you add one unit of a scarce resource, what would be the new contribution? What would be the new contribution? By increasing the constraints by 1. By increasing the constraint by 1. Let's quickly do that so that we conclude. So we have two equation machine. Average price. We have two equation. Machining. We have M plus what? 2R plus 2R equal to what? 700. We have assembling. We have what? 2.5 M plus what? Plus 2R. We have it as what? 1,000. So for us to determine our shadow price, increase the constraints. Increase the constraints by 1. Now, when you increase the constraint by 1, you will now solve. Still using equation. So when we increase constraint by 1, M is M plus 2R equal to what? We want to increase the first constraint of machining by 1. It will be what? 701. 701. These will remain same. We'll still solve for the second equation too. We have 2.5 also is what? 2 Russo equal to what? 1,000. We'll still increase that of 1,000 too. But we'll first treat for the first equation first. So when you treat this, still we apply our simultaneous equation to get the value of M when we increase the hours for machining by 1. And we get the value of R when we increase the hours of machining by 1. So when you increase the hours, the maximum hours of machining, which is 700 to 701, by the addition of 1, what will be the value of M? What will be the value of M? So the value of M will be what? The value of M will be what? Will still be 2.5 M minus M. We have 1.5 M.
350.5.
And this will be what? This will be 0 equal to what? This will be 299. That is 1,000 minus 701. So the value of M will now be what? M will be equal to what? M will be equal to what? 299 divided by what?
199.33.
Okay, fine. So M will be equal to what? 199.33. So you can substitute the value of M into any of the equation above. So when you substitute the value of M, substitute the value of M into any of the equation above, what are we going to get? The value of R will be what? Into equation 1. Substitute the value of M into equation 1. This is equation 1. Equation 1. Equation 2. So it will now be what? M will be what? 199.33 plus value of R is what?
2R. Okay.
2R equal to what?
700.
Sorry. It should be 701. It should be 701. You know, we increase it to 701. Sorry. So avoid confusion. This is the new equation. Equation 1 Equation what? 2. So when you solve, the value of R will be what?
250.84.
250.34.
2.84.
0.84
Okay.
approximately.
So now, based on this, what will be the shadow price, the effect of the addition of 1? What will be the effect of the addition of 1?
That is the first computation minus this second one.
No, you need to get your contribution again based on these new results.
Okay.
So your contribution for Maso is what? Based on this, your contribution for Maso is what? That is 40, right? That is our contribution value.
Yeah, it's 40.
40M, right? Plus what? 40M
50
plus what?
50
50R. So now it will now be what? 40 into the bracket of what? 199 point what?
0.33
plus what?
plus 50 R.
Into the bracket of what? 250.84. 250.84. So when you compute this, what will be the new contribution?
Okay.
Based on this unit produced. When
That's
you
20.
increase, okay?
1,515.2.
515.2. So what is the existing highest contribution?
20,500.
2,500.
Fine, 2,500. So the result will now be what? The shadow price for machining is now what? Shadow price for machining
15.2
will now be what? New contribution. New
Sir, you can
contribution.
help us build it a bit more.
New contribution is what? 20,515. Less old contribution or existing contribution. The old contribution is what? 2,500. So what is the increase? The effect of you adding 1 hour to 700?
15.
It's
15.
15. So that is the shadow price. That is the concept of shadow price, because it can be elaborated as if it's one very big thing. This is for machining. So for
assembly.
For assembling, can you quickly do that? For assembling, can you quickly do that? Let me get for assembling. What will be the results? Shadow price for assembly.
Well, neat.
What's the real connection with the body? She's just lucky, that's all. That's gonna be all that face. Well, the old man, but the man. The old man was just chasing bubbles in the soup kitchen. Absolutely. No, why can't eat dirt? See if you can still laugh.
Oh, our shadow price is what? What is the result? What is the effect of the shadow price?
We'll see on it, sir.
Okay.
It's 6 naira, sir.
6 naira? Can you confirm again? What are we?
It's 10 naira, go.
10 naira.
Okay, fine.
It's 10 naira.
10 naira. So when you add 1 hour to assembly, the extra contribution you will get is what? It's 10. So this is a concept of shadow price. So let's now go back to our past question. Let's go and look for a question to serve as an assignment, so that you can now say you know linear programming. Let's go back here.
You wanted to give flowers to Dad. I want her to get flowers. I want her to share.
So
Hello, sir.
Sir.
yes, ma'am.
Sir, I actually didn't get how you got the 250.8 in the 84 in the machining, and then the 24.9.66 in the assembly. I don't know how you got that. I tried it, but I'm not getting. I don't know whether I'm supposed to divide or times. Please, can
This
you
is
share
it.
more data on it?
This is it, ma'am. From my own solution. When you add 1 to 1,000, you have 1,001. Now you 2R is common to both. You minus 0. 2.5 m minus m is 1.5 m. 1001 minus 700 is 301. To get the value of m, 301 divided by 1.5, you have m to be what? 2067. So you can substitute this value into any of the equation above, which we substitute into equation 1, this one. So you have it as what? When you substitute m is here, you just replace m by 2067.67. You have 2000.67 plus 2r equal to what? 700. When you solve, you move this value to the other side of the equation, it becomes minus. So you have 2r 700 minus 2000.67, 200.67. You have 2r equal to what? 499.33. Make r result of the formula. R is equal to what? 499.33 divided by what? 2. You have R is equal to 249.66. Can you punch that on your calculator? Let's see.
Okay, I got it. I got where I made a mistake. I used 1000 instead of 700 when I got to the substitution aspect.
No, you can substitute into 1001. So you should have 249 points. Any of the equation, you should have same results.
Okay.
Yes. In any of the
All right.
equation.
Thank you, sir. All right.
Instead,
Thank you.
instead of 1001, to substitute
Excuse
into
me, sir. Please, my own new contribution is giving me 20,511. I want to confirm it where I don't know why I'm not getting the same answer with others.
Maybe it's approximation.
Yes, I approximated some people.
Okay. Maybe that is where the problem is coming from. So please, use your Bible now. Write this question. Just the year. November 2023, question 1. November 2023, question 1. Oshimiri Nigeria Limited. You refer to it in your ICANN question. The question says, identify the objective function and the constraints of the model to be used in determining the optimum production plan for the following month. Determine the optimum production plan for the month and the associated profits. Explain the concept and significance of dual prices and slack variables. When we talk about dual, I said it is what? It is shadow price. When we talk about slack, slack is the limitation where you have excess of resources. That is where you have slack. Another word for slack is what? Spare capacity. If you look at my screen, you'll see it. In the previous example, I said there were limits on the resources available. However, there was no requirement to use all of the resources, only that we could not use more than the maximum available. So if the optimum solution results in using less than the maximum available of a particular resource, we have spare capacity of that resource or slack. So where you have excess, where there is no limitation, it means you have spare capacity. Another word for spare capacity is what? Is slack. Slack. Take note of that. So this question is saying that explain the concept and significance of dual prices and slack variables, the context of the model used by the company in this scenario. Calculate the dual prices for constraints identified in this scenario. Suggest ways in which management can overcome the capacity constraints identified above during the months of calculation. So take note, November 2023, question 1. Because I'm expecting linear programming, this diet again. So please solve, follow the steps. It's the same thing. There is no any big deal about the question. So you should be able to solve perfectly. And the question is also asking us to determine this same thing we've just done on shadow price is also in that question. The issue of maximum contribution less fixed costs to get profit is also there. So everything we've treated in class is what is tested in that question. That question was repeated in, if I'm not mistaken, is it 2024? 2024. I want to get there. Question was repeated. Or in, is it 2025? May 25? So
Wait, check. Okay. Ituruki Bujari.
so that question was repeated. So please do well to assess the question. I expect solutions to see your solutions. Try it on your own. Don't go and consult the answer. When you try it on your own, then you can now consult the answer in the Pathfinder. But set an examination condition for yourself and see how far you can go. Then the extent you can go will now tell you what you need to do again, and then you keep getting better. So thank you very much. We need to call it a day. We'll meet on Tuesday again for PM. And Mr. Obajide, is this a new hand you're raising? Oh, okay, it's the old one. Okay, sir. All right. Thank you very much.
Okay. Thank you, sir.
Thank you, sir.
Yes, sir.
Now,